Greetings, ladies and gentlemen, boys and girls, kids of all ages. How you guys doing? So, how many people love homework? What? Okay. No, so we have this program called Sophia.org. How many people have not heard of it? Weird! Anyway, so here's the idea. Instead of going to class and listening to the teacher for the whole time, instead, the night before, you watch a little of the classroom, of the lecture, of the lesson at home, on your tablet, on your computer, on your phone. And then when you get to class, you have more time with the teacher. That is, as we say in comedy writing, the premise of the bit. So this is Sophia.org, and here's a little something I did, I guess it was a couple years ago. Can we, as we say in the business, roll that video?
Hey, Bill Nye the Science Guy here with a classic demonstration involving fire and atmospheric pressure and some chemistry, some combustion chemistry. So here is a water balloon, a pretty small volume of water in a balloon on a glass classic milk bottle. The water balloon doesn't fit inside. But if one lights a fire in there with, say, this very small scrap of paper, some of the gas that's in the bottle right now will be driven out into the room. And the balloon will shake as the hot gases go by. But as soon as the fire goes out, atmospheric pressure pushes the balloon into the bottle as though driven by a giant's thumb. Well, anyway, the balloon is stuck, and I'll show you. If you grab the knot of this balloon, you can pick up the whole bottle. That's because air cannot get around the balloon back in the bottle. The balloon holds its shape in the bottle. But using an ordinary straw, this I guess is a coffee stirrer that's hollow, placing it next to the balloon, now air can go through the straw to the back of the balloon, and the balloon will distort and come right out, as if by magic. But it's not magic, my friends. It's science.
So let's say you did that at home over and over again. Then we were able to ask you a few questions. Let's try one. When the temperature of the air in the bottle goes up, the pressure in the bottle goes down. Is that true or false? The pressure goes up because the fire is making the molecules move faster, they expand. So the pressure is slightly higher. That's why the balloon was shaking on top. Let's try the next question. The pressure is lower inside the bottle because the oxygen is gone. True or false? Right on. By the way, an interesting point of interest. My colleague on the board of the Planetary Society, a dear friend of mine, a guy who spent the night in my guest room many times, a guy who knows the password to my wireless router, Neil deGrasse Tyson. At first, got this one wrong. Because his science teacher, many years ago, sort of approximated it or did a hand-waving explanation about how the oxygen was gone. It's not that the oxygen's gone. It's that all the gas has been driven out by the expanding, the oxygen and carbon dioxide, everything's been driven out. All right, when the hot gases in the bottle escape, the pressure inside the bottle goes down. Let's say the fire's gone out. Does the pressure go up or down inside the bottle? How many people say up? How many people say down? Yes, yes. So that one's true. Click. Bing, bing, bing. Now, Jay, tell us what they've won. You've won a new car. No, wait. No, wait. A little bit of an exaggeration. No, so can you imagine that you're at home and you have a milk bottle, or you acquire one, or you met somebody who lend you one, And you could do this over and over again until you figured out these subtle things. The reason this demonstration is so popular is because, first of all, it's just cool, right? The balloon's there, and then it goes in. And how many people grew up with a hard-boiled egg? Same, so you can do the same demonstration. My friends, I am so old. How old are you? I am so old. I remember when the milkman, and it was always a man, came to the house with milk bottles. Those were the days. And now milk bottles are making a comeback because everybody finds that glass is such a fantastic material to store liquids in. It's solid rock, yet you can see through it. Is it magic? No. It's, yes. And so you can do that demonstration over and over to figure out the subtleties, because it is a little surprising. The hot gases go past the balloon. When the fire goes out, atmospheric pressure pushes the balloon in. It's cool. It is part of the flipped classroom at sophia.org. What is the name of it? It is, yes, I love you guys. Now, enough messing around. It's time to do some science.